All right, so operations with polynomials. Let's dive right into this math. So hopefully remember what polynomials are. But if we don't, well, I know that the word polynomial can be broken up, right? So poly, that means many. Nomial means terms. So that just means many terms. Okay, so examples of these, you don't have to write these down. What would be like 2x plus 4? That's a polynomial. 9x to the 100th power plus x to the 90th plus 1. That's a polynomial. Z plus 10 minus z to the negative, or to the second power. Not negative. You can't have negatives. There are some rules on this, but that's a polynomial. Okay? We'll get more into this, but those are polynomials. Now, a monomial. That word is very hard for me. So, monomial is a constant, variable, or product of numbers and variables. Use the exponent rules to simplify monomials. So, a monomial is just one term. So, again, we can break this up. Mono means one, so one term. Okay? So let's just look at these. I want to give you some examples of monomials. That would be like 2x to the 4th, or 3xyz to the 9th, or negative 9zx squared. Okay, those are all monomials because they're only one term. Like that's a monomial. That is a monomial. That one is a monomial. Okay, so product rule. This should be review. I get that we just had a summer, so it's okay. X to the a power times x to the b power equals x to the a plus b. An example of that would be 2 to the 3rd power times 2 to the 2nd power would be 2 to the 3 plus 2 power, which is 2 to the 5th, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that'd be 32. Okay, power rule, that's like x to the a to the b power. Well, when you raise a power to a power, you multiply the powers. So if we have x to the 3rd, or 2 to the 3rd raised to the 2nd power, that's going to be 2 to the 3rd times 2, which is 2 to the 6th. I know that 2 to the 5th was 32, so 2 to the 6th is 64. You can check that in your calculator if you need to. Quotient rule, well, product is that's multiplication goes with adding. Well, division goes with subtraction. So x to the a divided by x to the b, that's x to the a minus b, which would be like 2 to the 3rd over 2 to the 2nd is 2 to the 3 minus 1, which is 2 to the 1st power, which is just 2. Negative exponent rule, this one's kind of the weird one. So if you have x to the negative a, that's the same as 1 over x to the a. So it just drops it into the denominator, or if it starts in the denominator and it's negative, it will pop it up to the top. Okay, so if you have 2 to the negative 3rd power, that's 1 over 2 to the 3rd, which 2 to the 3rd is 2 times 2 is 4 times 2 is 8, so that's 1/8. Okay, I should have wrote those out. And then anything to the 0 power, anything to the 0 power is 1. So 2 to the 0 is 1. 1,579,410 is also, to the 0 power is 1. Okay? So when adding or subtracting monomials, we have to combine like terms. So let's use our exponent rules to simplify this down. So I have negative 6 to the 4th times negative 1/4 squared. Well, let's remember our order of operations. So PEMDAS. PEMDAS. Yeah, don't you know what PEMDAS is? PEMDAS, so that's parentheses. Exponents. And this is the order you do things. Exponents, multiplication, and division. Those go at the same time, so the MD. And the AS, that's addition and subtraction. Okay, so parentheses is always first. You always want to get rid of those first. Then you do your exponents, then you do multiplication and division, and then you do addition and subtraction. These ones You always go left to right. Okay, so if you have like an addition and a subtraction, you just do whatever one comes first. If you have multiplication and division, do whatever one comes first. Okay? So if we look at this, we have negative 6 to the fourth times 1/4 to the second power. Well, we want to get rid of those parentheses first, so I'm going to distribute that squared in. So that's going to be negative 1 squared over 4 squared. And this arrow, I do this a lot in the videos, so I just want you to be familiar with it. That just is, it's the same as like an equal sign, but we're going to the next line, so that's why I put that little arrow there. It just means that I'm continually working down. Okay? So 6 to the fourth, that's 1,296. The negative didn't get squared to the, or didn't get raised to that power. Negative 2 to the fourth, or negative 1 to the fourth, sorry, struggling. Negative 1 to the second, wow, sorry. Negative 1 to the second is 1. 4 to the second is 16. Okay? Now we got rid of those parentheses, we got rid of all the exponents, so now we can just multiply. So we have negative 1,296 divided by 16, which equals negative 81. Okay, let's do B. So 2 to the 0 power over 3 to the negative 1 power, all raised to the negative second power. Well, let's do parentheses first. So we're going to simplify inside those parentheses. Well, anything to the 0 power is 1. So that 5 to the 0 becomes 1. Over 3 to the negative first to the negative second power. Now remember that weird negative rule? A negative is going to, since that negative was in the bottom here, it's going to pop it up to the top and it's going to become positive. So this becomes 3 to the first power. Now we have a power raised to a power. Or you could get rid of the power. So this is the same. Sorry, so I make these videos and sometimes forget what I do. But the first, you don't have to put an exponent when something's raised to the first power. That's basically what that's saying. Okay? Now we have 3 to the negative second power. Again, we have that negative exponent rule, so that's going to be 3 to the negative second, which drops it down into the denominator. So that's 1 over 3 squared, which 3 squared is 9, so that's 1 over 9. Okay, let's do this one. So now we have some variables in here. So I have negative 3p to the negative second power times 8p to the 6th power. We don't have parentheses. Let's deal with our exponent. So I'm going to rearrange this. So with multiplication, you can always rearrange your terms. So I have a negative 3 times p to the negative second times 8 times p to the 6th. Well, I can rearrange that. So that's negative 3 times 8 times p to the negative second times p to the 6th. Okay? Now, negative 3 times 8, that's negative 24. But p to the negative second times p to the 6th, that's the addition rule. So that's p to the negative second plus 6, which is negative 24 p to the 4th power. Okay? You could have gotten to the same answer if you did that just a little bit differently, if you did like an exponent rule there. But either way, you'll get the same thing. Okay, that's one thing in math, and that's one thing I need to make very clear right now since this is one of the beginning videos. I am not a stickler on steps, okay? I need to know the steps you're doing because I need to see what you're working through logically. But if you do your steps a little bit differently but end up at the same answer and you can justify it, that is completely fine. The justification is what's important, okay? Not the answer, the steps to get there, okay? Now let's do this ugly thing. So 57x to the fourth, y to the negative second, divided by 3x, y to the negative third, minus 11x third, y. Now let's deal with that division first, right? So we have 57 over 3, x to the 4 minus 1, because the x to the fourth and the x on the bottom. And then y to the negative second minus negative 3, because division, that goes with subtraction. Now 57 divided by 3 is 19. 4 minus 1 is 3. Negative 2 minus a negative 3 is 1. Okay, I want you to think about this for a second. So if we have negative 2, we're at 0. We go negative 2. And negative 3. Well, subtraction is the same as the difference between them. Okay? So negative 2 to negative 3. we went, if you always started the second number, so this one, and then you go back to -2, right? So we went +1, which is why that's a 1. I want to do another one of these. This is just like a little side thing. I'll be fast. Sorry, this video is going to end up being longer. But, so say you had like -5 minus -9. Okay, so here's 0, here's -5, here's -9. We start at this one. And then you go up to -5. That is +4. Okay, I'll do one more. So say you had like 4 minus, -4 minus -3, or -2. Or let's just do +2. -4 minus 2. So 0, -4, 2. Well, you always start here, and then we went backwards, so that's -6. So that would be -6. Okay, that's just a little trick to subtracting negatives or dealing with subtraction. If you want me to do more of a lesson on that, you're going to have to come ask me individually. But now, so we have 19x cubed y minus 11x cubed y, which ends up being 8x cubed y. Let's do this one. So let's deal with parentheses first. So that's going to be -4 squared, r cubed to the second power, and then s squared. Well, -4 squared is 16. R to the 3, r cubed to the second power is r to the 3 times 2 power, and then s squared. So that's 3/4, r to the -2nd, s to the 5th, times 16, r to the 6th, s to the 2nd. Well, now this is all multiplication rules. So we have 3/4 times 16 times r to the -2nd plus 6, s to the 5 plus 2, which ends up being 12, r to the 4th, s to the 7th. One more. Let's simplify this. So that's going to be -18 over 42, a to the 8th minus 5, b to the 4 minus 7. That simplifies down to 3/7. Good rule of thumb, always leave numbers in their fraction form. Okay, unless like the decimal makes more sense for some reason. But most of the time, leave it in fraction form. And then a to the 3rd, b to the -3rd. Well, that negative needs to go away. So that's going to be -3 a to the 3rd over 7 b to the 3rd. Okay, I want you guys to try G and H. We'll go over them in class. Now, a polynomial is the sum or difference of many monomials. The highest exponent of a polynomial is called the degree, and standard form is when the degrees go from greatest to least. Okay, so let's classify these based on their degree. So 0 is constant, so that's like 1, 2, 3, 4, any number. 1 is linear, and that'd be like x, 4n, 3y plus 2. So the first degree. So see how the power on all of these would just be 1, 1, 1. That's what I'm talking about. Degree is the same as power. Highest power. Okay. 2 would be quadratic, so that'd be like x squared, -12r to the 2nd, 3z squared plus z plus 1, continued, okay. Cubic is the 3rd power. There's some examples of that. Quartic is the 4th power. Quintic is the 5th power. Now, you can also classify these by number of terms. So 1 is monomial, so there's only one term. 2 is binomial. 3 is trinomial. And then after that, we just call them polynomials. Okay, so we only really classify monomial, binomial, and trinomial. So adding and subtracting these, really all you're doing here is combining like terms. Okay, so we're going to get our b squareds together, we're going to get our b's together, we're going to get our constants together. So we have b squared plus 8b squared plus 5b minus 2b plus -11 plus -7. So that's 9b squared plus 3b minus 18. Let's do this one. Now this is a subtraction one. So on subtraction, you must distribute the negative first. If you do not do this, you will get it wrong. I promise. So the negative only distributes to the second parenthesis. So that becomes a plus sign, and that becomes negative 9, negative 3w squared, and negative 7w. So really what I did there is went like this. Okay? And now it's the same exact problem as the one before. We're combining like terms. So 3w squared minus 3w squared is going to cancel. 2w plus negative 7w, negative 5w. Negative 6 plus negative 9 is negative 15. Okay, I want you to do examples K and L. You're very capable of these. You can do it. Now multiplying polynomials. So I'm going to go over 2 ways. I don't care which way you decide to do it. You may prefer a different method than I prefer, and that's okay as long as you get the right answer. So the first way we're going to do this is distribution. So x minus 3 times 6x minus 7. Well, if you distribute, we're going to multiply x to 6x, x to negative 7, and you get 6x squared minus 7x. Then we're going to take the second term, so the negative 3, and multiply it to the 6x, multiply it to the negative 7. Negative 3 times 6x is negative 18x. Negative 3 times negative 7 is 21. Notice how I kind of left an indent here? I did that on purpose to get those to line up. Okay? And then we can just add straight down. So that'd be 6x squared minus 25x plus 21. Another way to do this is the box method. So say we have a 2 by 2 box because we have x minus 3, 2 terms, 6x minus 7, 2 terms. And then we're just finding the area of each box. So 6x times x is 6x squared. 6x times negative 3 is negative 18x. X times negative 7 is negative 7x. Negative 3 times negative 7 is 21. Pull those out of the box, combine these two right here, and you still get 6x squared minus 25x plus 21. 2 different methods, same answer. There are other methods out there. If you can prove to me that you can get the right answer every single time, I'm good with it. Okay? Now let's do this one. This is just distribution. So negative 2t times 10t is negative 2t squared. Negative 2t times negative 9 is 18t. Hint on negatives, multiplying negatives. Sorry, my handwriting is not very good on this thing. But if you have a negative times a positive, you will always get a negative. So if these are different, you always end up with a negative. Now if you have a negative times a negative or a positive times a positive, they will always be positive. So if these are the same, you always end up with a positive answer. Okay? So this one, so 4j minus 7k squared. Now that squared means we have 2 of them. Okay, you cannot just distribute that in. Does not work like that. Okay, that squared means that we have 2 of them. So that means we have 4j minus 7k times 4j minus 7k. Then we can multiply that out. I'm going to use the box. So that's going to be 16j squared minus 28jk minus 28jk plus 49k squared. And you get 16j squared minus 56jk plus 49k squared. There's something special about this. Okay? Now let's look at this one. So we have 2v plus 3, 2v minus 3. So 2v plus 3, 2v minus 3. Well, that's 4v squared. 6v, negative 6v, negative 9. And you end up with 4v squared minus 9 because these cancel out. Okay? There's something special about both of these. See if you can figure it out. We'll talk about it possibly tomorrow. It might be a couple more days before we talk about it. But it will show up. By the end of this unit, it will show up. So see if you can figure it out. Okay? Remember to take the quiz. Sorry this video is a little longer than I anticipated. There were some side things I wanted to show you. But hopefully you get the gist of how these videos are going to work. And hopefully you are semi enjoying this. Okay, I will see you guys tomorrow. Bye.